All right, let's talk about ratios. Here we have area ratios of similar figures. So we're dealing with the areas and the perimeters here. For theorem 87-1, that's on page 567. There's a theorem stating if they have similar figures, then their area, so let's say the ratio is A comma B, so it could be 7 comma 1 or semicolon 1. It could be anything. So for perimeter, it's A to B, so it stays the same for the ratio. But for the area, you square both of them so you can find their actual ratio for them. So let's do example 2. We're going to go ahead and ignore example 1. Example 2 here is ask you, let me go ahead and turn there. It says determine the perimeter of the larger shape. So here, they gave us a couple things. So here at the side is 4x. I believe they're rectangles. It just says shape, so it doesn't say anything about what type of shape it is. But we know for perimeters, you just add up all the sides. So here we have 4x for a side, we have 12x for the other side. We know that one perimeter is 50. We have to find the perimeter of the other one. So what we can do to solve for this is go ahead and find our ratio. Our ratio is what we always have to start with. We always need that. So you're comparing one object to the other. That's what ratio is. So I'm going to compare, they did the larger one to the smaller one. It honestly doesn't matter which one you compare it to. So the larger one compared to the smaller one. So we have 12x over 4x. For ratios, you can simplify them. The x's cancel out. 4 can go into both 12 and 4. 4 goes into 4 once. 4 goes into 12 3 times. So now we have our new ratio being 3 over 1. So we want a number on both the top and bottom. And now what we do is we create ratios, meaning fraction bar, equal sign, fraction bar. So everything on the fraction bar for the top has to be with one shape. Everything on the bottom has to be compared to the other one. So let's do 3 to 1. That's the ratio we have here. 3 I will consider as being my larger shape here. I'm just going to put it here, just a little key from the side for me. And then 1 is considered my smaller one, so I'm going to leave it there. So I have 3 to 1. This is my ratio. Here I'm going to put the perimeters. So this is my ratio. I'm going to put the perimeters of both of them. I have one of the perimeters. I have the perimeters of the smaller one being 50. So when I'm labeling it here, my smaller, they all have to be connected to the sides. So I'm going to put my smaller one down here. And for my larger one, we don't have a perimeter for there, so I'm going to put P. I'm just going to put P all. You can put just P there. This just helps me to know that it's the larger shape. Now we have our ratios. We have our two fractions. We set them equal to each other, and we cross multiply. So 1 times P, which is P, the perimeter of the larger one, is equal to 3 times 50. And to solve for that, you do 3 times 5, which is 15. Add the 0 from the end. So now your perimeter for the larger area is 150. Again, you only need to put the number 150. Do not put the CMs. You guys are still putting them on. I don't know how many times I have to tell you. Just put just the number there. Example 3, we have a ratio, 2 to 5. They want us to help find the area of the smaller one. So they want us to help find the area of the smaller one, but when we have to look for one of the areas of the smaller one, we have to make sure we have at least one of the areas. They don't give us the area of this one, but we can go ahead and find it. We can find the area because we know the area is 1/2 times base times height. The base is 25. The height is 40. And then you multiply it. So half of 40 is 20. 25 times 20 is 500. So now my area of my larger shape, my larger triangle is 500. I have my ratio. I can go ahead and create equation or create fractions and set them equal to each other. The first one I want to do is my ratios, but before we do that, if we look over here according to this theorem, we have to square both of the ratios before we go ahead and solve for this. So I'm just going to do this on the side here. So we have to do 2 squared to 5 squared. We end up with 4 to 25. So we're not using the 2 to 5, we're using, according to this theorem, we're squaring both of the ratios before we even use it to help us solve for a missing side. So now our new ratio is 425. Again, this only goes for areas and not perimeter. That's why we didn't do it for example 2. Now we have 4 over 25. 4 I would say for the smaller shape, and then 25 for the larger one. It really doesn't matter which one you have, small or larger on top. They'll give you the same answer anyways. But when you label them, you have to make sure you label them correctly. out of the areas here, we're looking for the area of the smaller one. So smaller here, I'm going to put area of the smaller one. But we have the area of the larger one, which is 500. So now, from this point, we go ahead and cross multiply. So we have 4 times 500 is equal to 25 times your area of your smaller one. So now we go ahead and multiply. 4 times 5 is 20. Add the 2 zeros. 25 area of the smaller one. You want the area of the smaller one by itself. Divide both sides by 25. And then the area of the smaller one now is 80. So this is 80 and this is 500. And this will be your answer. I just put the A sub S to tell us which one's the larger one and smaller one. Last one, it's a word problem. It looks like we have a trapezoid of a garden. So this is the design of the garden. This is not the actual size of the garden. So this is like a sketch or blueprint of the garden. So here we have the diagram. They said the ratio of the perimeter is 2 to 355. We're trying to find the perimeter of the larger one because they want to build something on the outside. So what that means is we need 2 perimeters. The perimeter of the smaller one and the perimeter of the larger one. The perimeter of the smaller one we don't even have, but we can easily find it because they gave us the diagram, they gave us a blueprint here. To find the perimeter, all we do is add up all the sides. So that's 5 plus 8 plus 5 plus 14. And the perimeter for that would be 32. Perimeter of the larger one, we don't have, so we can go ahead and find it. If you notice in the book, it says find the perimeter and area of the actual garden. So the actual one is like the larger scale one. So now, let's go ahead and find the perimeter of the larger one. We have to use the ratios. Remember, for perimeters, we don't square the ratios, we leave the ratios as is. So then we have 2 over 355. We set it equal to, and here I'm just going to label on the side. I know that the smaller number always refers to the smaller shape, a smaller figure. So I have small here over the large, which is a 355. And that's the ratio of the 2. We have here the perimeter of the smaller one is 32. We don't have the perimeter of the actual one. So I'm just going to put A. Let me just put A. The perimeter of the actual one. So now to find it, we cross multiply. So now we have 2 times P, the perimeter of the actual one, is equal to 355 times 32. That will be 11,360. And then we have the 2 times perimeter A. We want the perimeter by itself because we're trying to look for that. That means the perimeter of the actual shape, the actual garden, is 5,680. So 5,680 is the perimeter of the actual one. But now, let's go ahead and find the area. So we did all of this for the area, or for the perimeter. Now for the area of the diagram, I'm just going to put the smaller one. We have to look for. We don't have anything, they just gave us a diagram, but the diagram is enough work for us to work with. Here, the area of the smaller one, we know the area of a trapezoid is 1/2 times base 1 plus base 2 times your height. So for the smaller shape, we can go ahead and plug it in. 1/2, base 1 is 8, base 2 is 14. Doesn't matter which order you put them in, the height is 4. Half of 4 is 2. 8 plus 4 times 2 is 44. That will be 22. Multiplied by 2 is 44. So the area of the smaller one is 44, but that's not what we're looking for. We're looking for the perimeter and area of the actual garden itself. Now, let's go ahead and create our proportions. Keep in mind, for ratios, if we are looking for the area, we have to square it. So the perimeter, we just leave it the same. For our area, we have to square it. When we square, we get 4 to 1,026.25. Now, let's go ahead and set up our proportions. The numbers get a lot larger from here. So 4 over 126, 0.25. So I know the 4 resembles a smaller shape, and the 126.25 resembles the actual size of the garden. So now here we have the area of the smaller one, which is 44. We don't have the area of the actual one, so that's what we're going to look for. Go ahead and cross multiply. I'm going to do that over here. And the numbers get very large from here. So 4 times A sub A, 126,000 times 44. I get 5,545,100. So I already multiplied that, I skipped that step. Here I want the area by itself, I'm dividing both sides by 4, and the area of the actual shape is 1,386,275. So the perimeter is that, the area is that, but we're using the similar ratios to solve for each one of them. So if you guys need any more help, make sure to let me know down there on my email. Let me see you guys. Have a good day.